Hi, this is Jacob Nash with JNGL, and this is Unit 5, Lesson 2, and this one's on reflections, Standard 5.2. What is a reflection? It is a type of transformation in which a geometric figure, not geometry figure, is flipped across a line of reflection. A line of reflection, you'll be asked to reflect something. So let's say this green figure is what you start out with. If you need to reflect it, or actually, I'll make it more like this. If you need to reflect it, it's unlike transformations. It's not just going to look the same. It's actually going to flip, like when you're looking in a mirror, you see your reflection, and that blue one would be the new one, and the purple would be what the line of reflection is. And sometimes it will be easy, and sometimes it won't be. So that's the difference. You probably already learned this, but if you there's something that's new that you might not know. So, is it a rigid motion? We talked about that on the other video. It is, and that all that means is that is the pre-image congruent to second. Congruent doesn't mean they have to look exactly the same. These green and blue don't look exactly the same, but they are congruent, even though they don't look like it because I didn't draw them completely right. But they're supposed to be congruent. Like if the area of this one was 7, that one would have to be 7. Because if it wasn't, then it wouldn't be a correct reflection. But here's some quick tricks. If you're asked to reflect things, there are certain things you can do where you don't even have to graph. So, if you're asked to reflect something across an x-axis, the y goes to a negative. Now, that doesn't mean that it just changes to a negative. It means that it has an opposite sign. So 5, if you had that one, then you would just make it negative. But if you had -1, then you make that negative and you plug it in, -1. So when you have two negatives, it just goes to a positive. So it would just be 1 in the first place. So that's what that means. If you're reflecting across a y-axis, then the x changes. So you just change whatever thing the axis is not, pretty much. If you're across the y equals x axis, well, you might not know what kind of axis that is, and all that is just, if you go back to y equals mx plus b, well, what is m? It's not shown. It's always 1 if it's by the x, and then b is the y-intercept. There is none, so you can tell that it goes through 0, 0. So it will go through both the y and x axis as an origin point. So this would be the y equals x. Y equals negative x would go like this, pointed like that, and have a negative slope. But what you do for those, when it's the y equals x, you flip the x and y. So if it was 1, 2, then it turns to 2, 1. You do the same thing for y equals negative x, except for you change their values. Again, that doesn't mean that it's going to negative. Like, if it already was like this, then it would change to positives. Or if it was positives, then it would change to negatives. So that's what you do. So some practice. Well, what if there's no trick? What should you do? Well, this isn't really practice, but this is just this is the hardest thing that you might have to do. So when we knew our what was it? Our equations for the translations, we knew the one that was what was it? For the one that was function notation, that this kind of the function notation is uppercase R, which means reflection, and then line. So you're reflecting over what line? So saying reflect triangle stew. So reflect triangle stew over the x plus 3 axis. So it's not going through the origin this time. How do you determine what that is? Well, think of it in terms of what is the m and the b. The m is just going to be 1 because there's nothing there, and this is the 3. So you pretty much, that's what's happening each time. So we know that it's going to have a y-intercept of 3. So 1, 2, 3, and then if it's x, if it's just x, then it's going to just cut through the boxes diagonally because it goes up 1 over 1, up 1 over 1. but it really just cuts through these boxes diagonally, just like this. Oh, I think I did something wrong. There we go. So this would be that line. And you're supposed to reflect stew. Well, here's the problem about this, is that one of the things is, like, part of the figure is already over the line. So really, this U right here is going to come on the other side, and this ST is going to come on this side. So when I draw the other figure, it's going to overlap the one that was originally there. But anyways, here's, instead of just counting boxes like with a straight line that follows the grid lines, instead you count diagonal boxes. So U is from this, it is one diagonal box away from it. So you could see that there was this box, U was right here, the line was right here. So instead you go one more this way. So right here. That might seem kind of confusing. I wish I wouldn't have chosen something that overlaps. But that's where U prime would be. And then T, well, from this line, it is 1, 2 diagonal boxes over. So instead, this way, 1, 2. So T prime would be right here. So T prime. And then S. S, well, we just choose a point. This is not drawn. Let's see. Yeah, this is actually a little off. This line's supposed to go through this point. So it goes 1, 2. Oh, wait a second. No. We should go this. Oh, okay. Never mind. If it's on this, 1, 2. So you go over 1, 2. It's there, right here. Sorry about that. That was kind of confusing. I once again, I wish it wouldn't have overlapped like this. So now I'm going to draw in green the new figure, what it looks like. And does it match up with the purple one? It does. And even though you might say, well, that doesn't really look like a reflection. Well, that's what it would be over an axis like that. You still see the same features. It just was like this. Now it's kind of like this. And since it doesn't look directly reflected, because we're not over a straight line, we're over a diagonal line. So that's the most complicated thing you might have to do in this whole unit. So if you understand that, good. If you don't, email me at, I'll type it. This is my email, jacobnash747@gmail.com. Once again, I already have said this before, it's not dot you see I switched the C and dot, but anyways, once again, if it is 2030, well, do you think I might even really still have that email? Maybe not. So see when this video is published. It was published March 5th, 2020. If it's years from then, chances are I might not have that email anymore. So if that's the case, then you might want to just watch someone else's video for this standard. So thank you. Thank you for watching there. Thanks for watching.